Hello everyone, and welcome back to another episode of Let's Code a Mining Turtle. This is Selek, and first of all I want to say thank you all for your patience. It's been like a couple of weeks since the last episode came out, and I wanted to let you guys know a little bit about my plans for this. Just sort of a tease a little bit. This program that we are working on is actually going to be crucial, a big part of what I'm going to be doing next in Feed the Beast. Now, if any of you watch my Cloud Town episodes, you will have heard, at least the most recent one, you will have heard that I am going to be discontinuing my current FTB series using the Minecraft pack, primarily because it's still in 1.4.7 and Red Power 2 is going to be discontinued, and like 80% of what I'm doing in that world is red power based. So what I'm going to be doing is soon I'm going to be starting up a new world, and I'm going to be using the new FTB pack called Unleashed, FTB Unleashed. And of course it includes computer craft, and computer craft is going to be a major part of what I do there. So what we are doing in these episodes, Building the Better Excavate, we're going to be building more programs. So hang in there, hang tight. I plan on doing about one of these a week as I have time. It's definitely a long-term kind of thing. So thank you all for your questions and comments and all that kind of stuff too. Yeah, so we're just going to go ahead and jump right in, sort of review where we left off, and where we're headed. So when we left off, I think I might have adjusted this a little bit, but we'd made a dig function that dug basically a square, a size by size square, and then we kept track of it. We made sure we did a little testing here. We kept track of it to make sure we knew where things were. And but today, in today's episode, after doing some thinking and tinkering around a little bit, we're going to do some refactoring straight away. If you don't know what refactoring is, you're going to find out. And then we're going to hopefully do some more, I should say, I guess, advanced things. I'm going to be introducing a more complex data type in Lua. So if you're new to Lua, it'll be interesting to you. If you're not new to Lua, then it won't be very interesting to you. So yeah, let's go ahead and jump right in. So what I wanted to do is I want to make basically I want to combine some of these functions here, and we are going to keep track of our coordinates in a different way. Now, many of you, like I said, if you're experienced with Lua, you will know what a table is. In Lua, a table is a general collection. Java has arrays and lists and those kinds of things. Well, the only type of collection in Lua is a table. The cool thing is it's super flexible. It reminds me a little bit of Python. Python has some very flexible collections. The table it can act like a linked list. It can act like a map. It can act like an array. It can act like a lot of different things. A dictionary, I think, is the term in Python. And so we're going to be using that. So let's go ahead and start off right away with that. So what we're going to do is we're going to track our current position. Make sure it's local. Current position. And we're going to say, and this is how you define a table. The brackets here means it's a table. So we're going to have an x coordinates, a y coordinates, z coordinates, and a direction. Now we could easily handle this right here, this little section, with a vector. Hello. Okay, that was weird. So we could easily handle this with a vector, which is another data type in Lua, but we're going to go ahead and make our own little map of our coordinates. And we're also going to have a way to save a position. So we're going to have a saved position, and it's going to be the same thing. So let's just go ahead and copy this on down. And this will all make sense shortly. So now we need we're going to go ahead and do a home position as well. So this is going to be the position where we plant the turtle. It's going to know where to go home when it needs to go home. And we'll do the same thing, copying, book. And just for kicks and readability. So much of programming I read today, programming, I don't know what the percentage is, but the majority of programming is actually reading what you've programmed. So it's important to be able to read it. So we're going to get rid of these things, and we're going to be using collections. Now, so let's go ahead and jump in right here. Now that we have our collection, we'll go ahead and work on this, I guess. Instead of the dig, we'll work on making this a little bit of a better function. So I have a little bit of a reference here. I'm going to be checking it out. Down here. Okay. So what I'm going to do is I'm going to consolidate these go, back, forward, and up, down into one go function. So type function go. And what we're going to do is we're going to pass in a string. All right. And I cannot spell function, clearly. But the nice thing is that's what I like about Sublime text is hey, I didn't write that right. Okay, so now what we're going to do is we are going to have a way to read the string, and we're going to pass in something like this. So we're going to say if string dot lower, and this is just a way of normalizing the text that's passed in. So we're going to be able to pass in a text that is either equal to down or string dot lower D, not F. So if, oops, make more sense if I say this. There we go. So if we pass in a string that is down or D, then we are going to learn how to type. There we go. So then we will go down. But we're going to use one of the neat things about the turtle.down function sends your turtle down, but it also returns a Boolean if it's successful. So instead of saying just turtle.down, we're going to say if turtle.down. So it's going to, not only is it going to go down, it's going to give us a value. So if it's true, if it works, then we're going to update our position. Now, we've changed our position collection into a table. Instead of having X, Y, Z, and D, we have it in a collection. So the way we call the X coordinate, or I guess in this situation, since we're going down, we'll be calling the Y coordinate, is we pass in the key. Now this is what I did here. I gave it a key. X is the key, and 0 is the value. Y the key, 0 the value. Key value over and over again. So we're going to say current position. There we go, current position. We're going to use this square bracket Y. So we're going to update this current position by saying current position equals current position. I mean, is it going to work? No. I'm trying to use the fuzzy search here. Current position. So we're going to take the value and we are going to -1. Yep, because we're going down. Okay, so we are going to end that. And oops, and in this. Now, one of the cool things about Python, one of the cool things about Lua is you can do something like this. If you have only one line of your if statement, and actually I know it's true of a lot of different languages, but it's a little more of a convention in Lua to keep your, I guess, stuff, I was going to say code, stuff, whatever, as concise as possible. But what I'm going to do is, if it's a one-line piece of code, then I'm going to go ahead and put it up here. But if there's a block, there's actually a couple of things within the if statement or the for loop or whatever it may be, I'm actually going to make it, leave it at 2 lines. Because what we're going to do here is we're going to have go actually return something for us. We're going to have it return a Boolean value. So we're going to go ahead and initialize that guy. So go ahead and set it to false. But in this case, since the turtle has actually gone down, then we're going to say that it was successful. So we'll say success oops, equals true. Okay. Now, if it's not, we're going to give it some intelligence here. And so instead of saying in there, we're actually going to do else. And we're going to go ahead for now and write to the terminal. Eventually, we're going to actually have sort of a message system so that we can actually know what the turtle is, where it's at, that kind of thing. But for now, we'll just go ahead and say, I'm stuck. So we know that it tried to go down, but it couldn't. And we put that in the wrong place. You just go right here. Okay. Doot, 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 doot. There we go. That's it. Okay, so now it tried to go down, it couldn't, so it writes out to the terminal that it's stuck. Now let's do this again. We're going to go ahead and say if string.lower stir is equal to up or you. So let's go actually just do this. Now you can get in trouble doing this kind of thing, but if you pay close attention, it will actually help save time. So we're going to go ahead and change this to up or U. And then this is going to be a +1. And is that it? Turtle.up. Here we go. Okay, so then we have, let's do forward. Forward or F. We're going to say forward. Oops. But now we are going to change the coordinate depending on what it's doing here. So let's go ahead and pull these in for forward. If you remember, we change the X or the Z depending on which direction it's facing. So let's go over here and then we will say if forward, then we need to update the position intelligently. No. No. That's weird. Why is that not working the way I think it should? Let's try this again. Tab, tab, tab. Yeah. Okay. So instead of doing Z and X, remember we're going to be doing current position. So let's go ahead and pull these in. But this is going to be Z instead. So this is going to be X. Be changing the X value of current position. All right, change Z here. And then we will change, oops, yeah, change X again. X and then X. Okay, so let's get rid of this. So now we have our statements here ready to go. It will change our current position table, the value of Z and X. Okay, and then let's do it again for back. Go ahead and stick this right here. Oops. And actually, I guess I can just, are they the same? They're almost the same, but we just have to change one plus or minus. So instead of plus here, it's minus, minus, and then plus and plus. See if that lines up. X, X, Z, X, Z, minus, plus, plus, minus. Yes, yes, yes. Okay. Oh, we got to change one more thing. Yes, this is back. So then we need to change this to back. B. Then back here. Now let's go ahead and check these. Okay, so we have a down, D, up, U, forward, F, B, back B. And then we are going to change the Y. If we go down -1, up +1, and then forward matches this, and then back matches that. ZX, ZX, minus, plus, plus, minus. Okay, looks good. So we're going to go ahead and get rid of these. Pew. Done. So now we have a single function that we can just pass in a string, and that will allow us to really just, it looks nicer and it makes more sense. And it will look better once we go and add the refactoring what we did to here as well. Okay, so now let's also refactor this. And so instead of having t right and t left, we're just going to have a function that's called turn. But we're going to do the same thing. We're going to pass in a string and do sort of the same idea here with with the turn. So as a matter of fact, let's go ahead and just grab this. Okay, go away. Oh, haha. One important thing. Did you notice it? We need to return our success. So that way we can have a little bit of intelligence. We can call this function and throw it in an if statement so we can know if we need to do something different. Or give us some sort of message that the go was not successful. All right, so our turn. So if the string is right or R, then turtle dot right. Now the thing is though, is we don't need, this thing can turn right with or without fuel. It doesn't really matter. Okay, so, but instead of, so we won't need a success either. So instead of having a current position, that's not what I wanted to do. There we go. Okay. So instead of doing current position, we're actually, current position Y, we're going to update the D. Just like that. And let's go ahead and throw in our mod function here. So, yep. Mod 4, make sure it's within the 0, 1, 2, or 3. And then, oops, it's not right. Turn right. There we go. Okay. Does that look right? Yeah, looks good. And so we won't need this as well. So let's go ahead and grab this, and we will do the same thing for, and we could just do an else here, but because that's all we're going to be passing in. We'll give ourselves a little leeway just in case we happen to misspell something. Okay, so if we do that, then we're going to turn left, and we are going to add. Is that correct? Okay, let's think about that. Oh, here it is. So adding, there we go. Adding for right, subtracting for left, having the mod so that it gets assigned properly. All right. So now we can just pass in turn and R or L or left or right, and that will do it for us. Very cool. All right, so now let's move on to our dig function here. Now what we're going to do is we're going to go ahead and have the size be passed in like this. And we need to think about going down. So I started to do a little bit of it, and I got a little confused on it. It was, it's not exactly maybe as intuitive as I would hope it would be initially. So we're going to sort of talk you through it, sort of what I've gone through, thinking about it. You can see I was even messing around with some of the variables here, variable names. And so we need to think about doing this in 3 dimensions. It gets a little interesting. Now, the first thing we want to do is we want it to go down indefinitely. We want it to go down until it hits bedrock, or it cannot go down any further. So we're going to go ahead and give ourselves a nice local Boolean value, and we're going to call it not at bedrock. How do you spell bedrock? We'll do it that way with a lowercase r. So now, the first thing we're going to do, the first thing we did before was we dug down. So we're going to do that again. So we're going to give ourselves, before I forget. We need one more helper function, and it's sort of a wrapper. And it is going to be, we're going to wrap our dig calls. And that way, it'll just simplify things a little bit more. And I like it that way. It gives them some consistency, because that's what we're doing here. We're essentially wrapping turtle.down, up, forward, and back, and also the turn. So let's go ahead and wrap the dig as well. So function dig, we're going to pass in the string again, end. And now this is gives us a success. So let's go ahead and pull this. We can grab go ahead and hit my return here before I forget. Return success. So we're going to have a dig down, and a dig up. So let us say, we'll just say, I guess we can, so you can say dig forward or just dig. Of course, dig down, we could abbreviate to D. So let's use forward for digging forward, which is just simply turtle.dig. But let's see. This, doon. So we're going to have a turtle.dig up, and a turtle.dig down. Okay, so we are not going to need to be updating anything. What we can do is this. Oops. And let's go ahead and kill this. And we'll just do an end, just like that. And then we need to... Why is that strange? Okay. Don't know. Then here, end. Okay. Bonk. So let's say, instead of forward, we're going to say up, or U. And then we are going to dig up. If dig up, then success. Okay. And then we'll end that. We'll get rid of this. Copy this guy. And instead of up, we will go down. Can't forget to end this. All right. And, you know, actually what we could do is we could do an else. And that will actually say, it's nitpicky. I'll have to agree with that. But you can, if you put in an else if, and then an else. Well, yeah. So let's just do that. Else. Okay, so here's the advantages and disadvantages to doing else and else if. If we get to this right here and we pass in a forward, it's not going to go through and check the rest of these. If we get to here and then to here and we pass in up, then it's not going to go down and check this. So it saves basically one cycle. And when you're dealing with things like embedded systems, limited resource systems, it's important to conserve that kind of thing. But maybe at this situation, it may not be as important. But we'll go ahead and we'll go ahead and do the else if this way. Okay, and so then we will say, oh, there's one thing we can do. Now this is something that I often forget, but we can say, instead of saying this, if something true, then success is true, we can just say success equals turtle.dig. And so that way, no matter what, it's gonna execute this function, this dig function, and it'll go ahead and assign it to that, and it's gonna save us a little bit of reading, aka legibility, when we come back and look at it later. So we can get rid of this. Okay, like that. And then another else if. And then success equals turtle dot dig down. All right, get rid of this and that. Yep. And what we can do, and so we're going to have sort of a else that's just hanging there. There's no else to it, and I think that's okay. Now we could put this all up in one line like this. See what that looks like. Oh, I like that. It's a little long, but it's okay. All right. There are so many different ways that you can program these things, and you can even do stuff like this. If you wanted to say, like, get it all nice and lined up, if you wanted to, that helps in readability. You know, that's a personal preference, though, for sure. Let's see, and we don't need an end here, and we don't need an end here because we changed that to else ifs. Okay, and then there we go. So, you know, that's actually a little more compact, a little more readable. Got to change that. See, already noticed something that we could change. Very cool. How does that look? Forward, down, up. Yep. Okay. So now we have wrapped our dig function, our go, or our forward, back, up and down, and then our turn. So now, getting back to the dig function here, we are going to dig, and we're going to dig down. So we're going to pass in D. Okay. And this. So we're going to assign it a Boolean. We're going to do a little bit of Boolean action here. So we're going to go down also. Okay, so what this will do is it's going to dig down and go down and going to take the results of both of those and pass it to not at bedrock. So obviously you can't go down, you can't dig down and go down if you're at bedrock. So it's going to be false for us. So that will allow us to do a while loop. So while we're not at bedrock, do. So we are going to do our for loops here. I changed it to the wrong variable. Okay. So now what we're going to also do is we're going to change this to a zero-based index. Now, it's a little bit of a nitpicky kind of thing, but oftentimes when you are doing, at least for me, when I'm doing more like interesting math, it helps to keep a consistent index. And so I'm going to go ahead and make it a 0 index. And so that means we need to subtract 1 from the size. So if we pass in the size 10, we're going to go from 0 to 9, which is 10. Now, one of the things, if you imagine this for a second, one of the problems or the interesting things about what the mining turtle is doing is it starts, let's say we had a square, and at the bottom of the square, the bottom left of the square is where the turtle starts. And so it's going to go up and then over and then down and over, up and over and over again until it gets to the final column. Now, if you have an even sized square, in other words, a 10 by 10, not an 11 by 11 or 13 by 13, but a 10 by 10, your turtle is going to end up going up, down, up, over, down, over, up, like this, over and over again. And it's actually going to end up, say 1, 2, 3, 4. That's right. It's going to end up in the bottom right corner. Now, if you do an odd size, like size 11, you're going to end up in the top right corner. So based on that, you're going to have to turn the turtle to know where to start again. So if you can imagine in your head, and it took me a while to do this. So as a matter of fact, we can actually go ahead and look over here. So this will help. So it goes this way, 1, right? Or 0 for us. 1, 2, 3. So in this case, since we are a 0-based, 0, 1, 2, 3, this is where our turtle is going to end up if we had a 3. So it would go 0, 1, 2, 3 to here, turn, go down to here, turn, go down to here, and then turn and go down to here. So it would end up making the opposite of this, essentially, cutting out this square right here. I guess I could just dig it out, right? So this is what it would dig out if we gave it 4. My point being that it ends up right here. So when it does that, all we're going to have it do is turn right and do it all over again, right? It's going to turn right, go down 1, and then do it all over again. But if we had an odd shaped one, so let's say we did a 5 by 5, it's going to go this way, this way, this way, this way, and it's going to end up right here. Now, what we want to do is we want to use the same loop that we have, so we actually need to turn it all the way around, and then it's going to go down 1 and go back this way, so that it makes sure that what the turtle is excavating is the square that it's excavating is always forward and to the right. And hopefully that makes sense to you. So let's go back to what we're doing here and think about our, let's go ahead and change this out while we're talking. So now instead of doing turtle.dig, we're going to say dig forward and go forward. And that's not right. Go forward. All right. Now, let's think about this if statement for a second. Since we are basically doing this a little bit differently now, because we've changed the index, our first row is going to be even. So if I is, I modulo 2 is 0. So if it is even, in other words, if it is the first, if you can imagine the first one, it's going to go up and it's going to turn right. Turn R. It's going to dig forward. Go forward. And then turn right again. Let's go ahead and replace these. Turn left. It's going to dig forward, go forward, and then turn left again. Now, so it's gone through and it's made its square. So now, based on what level it's on, we need to turn it the right direction. Let's go ahead and go down. So we're going to say not at bedrock. So if this is successful, same thing here, let's just copy it. So if it's successful again, it's not going to break out of the while loop. It's going to keep going. Now let's think about this. So now our y, we started at y equals 0. So here, okay, so here's what we need to think about. This needs to be a 0-based guy. Now we could use current position if that were our, if it were going to be starting at 0. We may not start it at 0. It may be something where we keep the actual position. One of my plans actually is to have the turtle know its coordinates at all times. So when you place it down, not only are you going to name it and give it fuel, you're also going to tell it its coordinates. So it will not lose track of where it's at in the world. So we need to think about maybe a better way to keep track of this. So one of the things we could do, be pretty simple, since this is going to be inside of our while loop, we could just declare a local variable, y. And the scope, as long as we don't have something above it, like up here, its scope will be local to this function and nothing will interfere with it. So we'll go ahead and set y equal to 0. Now let's do a little bit of working with it here. So if it is on the first level, so that means y equals 0 is equal to, sorry, y mod 2 equal to 0. And so if it's on the first row and the size is an odd size. Okay, so let's go back to our, oops. Let's go back to this right here. Oh, there we go. All right. So we're on the first row and we've gone through, it's odd, and we're here. Remember, we're facing like this. Sorry, we're facing like this. We came through right here. Now we need to turn around. So we can turn right or left, doesn't matter, but we need to turn all the way around. Now, if it were to have been even, we would have ended up here. So all we would need to do is turn once. Okay. So if we are on, and we could have said if it were an even size, we're going to go ahead and do the odd size first. If it's an odd size and you're on an even row, then you're going to, sorry, an even level, an even y coordinate. You're going to turn right and turn right again. Else turn right once. Oops. End. Okay, so what does that mean? That means that if both of these conditions are true, we will orient ourselves in the proper direction. Now, let's imagine, let's go back to our turtle guy here. Now, let's say let's go back to being odd. Okay, so we ended up right here, right? Facing this direction. So now we turn around completely and we go down. And we're going to go all the way back. So let's go ahead and be a turtle here. So we go here, right? Here, here, then here, then here, here. Okay, so now we're in the same place again. So we need to turn all the way around and keep going. So let's imagine that we were, oops. Let's imagine that we were an even size. Okay, so now we're an even size, so we go this way, this way, this way. So we end up right here. We turn right once, and now we're going to go like this. I got all confused, didn't I? I'm not a very good turtle. Okay, so we're here, and we went like this. Oops. Here, bump, 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 bump. So all we need to do is turn right again. So actually, you know what? This is superfluous. Don't need it. So all we need to know is it even or is it odd? Because if it's odd, we're going to do a full 180. If it's an even, then we're just going to turn 90 degrees. And that's it. We can kill this. It's even better. Okay, so let's think about this. Review it for a moment. Does it make sense? Do you see what we're doing? So because we don't know where we're starting, we're not going to say, hey, we're starting at Y64 or whatever. We're starting at some point in the world. So we're going to say, well, we don't care where we are, just as long as we're not at bedrock. So how do we test if we're at bedrock? We have our dig, which returns a true or false. If we are successful at it, it will give us a true. And go. So if we're able to actually go down, so we are able to both dig down and go down. Now you don't, I mean, obviously if you can't dig down, you couldn't go down. Unless you can't, and see, this is I'm not sure about this, and we'll have to test this at some point. Does the dig function return false if it tries to dig an air block? I don't know, because if that's the case, then it's going to think we're at bedrock. So we might want to go ahead. We might think about turning this to an or. Maybe, maybe not, because if this for whatever reason returns false, it's going to think that we are at bedrock. So anyways, as long as this statement right here is true, we're going to do this while loop. And that's something we'll test in the future. I'm not too concerned about it right now. And so we have our loops, and we made it 0 indexed. And I'm actually, I think for now, I'm probably going to be making a lot of my indexes 0 0-based indexes, because that's what I'm used to. Okay, so this is true because we were able to dig down and go down, so we are not at bedrock. So then we go, and for this column, right, this is our column, and this is our row. Boop. Right. So we dig forward, we go forward. We've already dug down once and went down. So we dig, go, dig, go, dig, go until we get to the end. And once we get to the end, if it's on an even column, we turn right, dig forward, go forward, turn right again. If it's odd column, we turn left, dig forward, go forward, turn left again. And I need to change this because I changed my index on odd, on even. Okay, and then we check again. When we get to the end of it, we dig down, go down, making sure we're not at bedrock. Otherwise, we will break out of the while loop. And we could put this at the end. It doesn't really matter because, as a matter of fact, let's just go ahead and do that. I think it's generally a convention that we're missing an end. Not good to miss an end. And that's what I really like about Sublime text is you have these really clear lines that show, hey, you haven't written this correctly. Fix it. So if our size mod 2 is equal to 1, in other words, if the size is odd, we will turn around. If the size is even, we'll just turn once, 90 degrees. Wow, that was a lot. I don't know how long this episode is, but we did quite a bit here. Turning, being able to sort of give ourselves a wrapper for the turn. I'll probably think about this a little bit more if there's a way we can do it more simply, or perhaps, I just like being able to pass in this kind of thing instead of having to, and it's not as verbose, because you're going to have to do this every time. I just like it because we have, instead of 2 turn functions, we have 1. Same with the go. Well, as I was looking through the code here, I noticed one very important thing that we need to take care of. We have 2 dig functions, and that's not going to work out too well for us. So since this is doing our excavating, we'll go ahead and just call that guy excavate. But I feel like we've made a lot of really good progress. We've refactored quite a bit. We have some nice helper functions that we will definitely be able to use in the future. And, next episode, we're going to be looking at tracking our fuel, making sure the turtle knows when to go back and grab some more fuel. And also when the track inventory function is under development so that it can make sure we dump all the items out if we get too many stacks in the inventory. But that will do it for this episode. I hope you guys enjoyed it. If you have any questions, do let me know in the comments. And if you enjoyed it, give me a thumbs up. I would really appreciate it. So yeah, looking forward to next episode, and I'll see you all again next time.